let's talk about dynamic memory allocation. This stuff is pretty cool. So in previous videos, you can check those out in the playlist link below the like button, where we've talked about pointers and other C++ concepts. But this is going to build off of what we've talked about for pointers. So let's go over a quick definition. Dynamic memory allocation. It can allocate storage for a variable while the program is running. We make the storage. We put the variable in that storage. We control it. So how does it work? Well, a computer returns the address of a newly allocated variable. It's going to use the new operator to allocate memory. So if you look at this example I have right here, you can see I have a type double. It's going to have the asterisk dptr. This is just the variable name. The asterisk is important because you need that for it to be a pointer. So in front of the name that you create, you need the asterisk becomes a pointer. And it's going to be set to a null pointer. So currently it's null. We've declared it and we've initialized it to a null pointer. This next line is pretty cool. So you're going to dynamically allocate memory for a double because we've declared it as a new double, and we're going to assign the address to dptr. So this is the pointer, right? And this is the address, and we're assigning it to each other, and we're setting it equal to a new double. So again, this first line, 26, you declare a pointer to double, initialize it to null pointer as well. The next line, you are dynamically allocating memory for a double, a new double, that's on the right side, and then you assign the address of it to dptr, assigning the address to this right here. And if I see out these next two lines, you'll see what it says. For this first one, dptr, we should just have the address. So we have the address here. And then for the asterisk, is to print the value here. The value is going to be 0 because we haven't filled anything inside of here yet. Now, remember, to get the value at that address, we're going to set the pointer, so the asterisk here. The pointer at this address is going to go to 12. And so that means our dptr now stores the double of 12. And so you can see that it's going to print out the same exact address because we made that address. We created it and we set it equal to a new double. We assigned it this new double, and then we're just printing out first the address, and then we're printing out the value at that address. You can do this with arrays, you can do this with characters, you can do this with strings. Explore it because it is a interesting concept to make your own memory points and manipulate them. However, be careful with memory leakage. You need to use delete to free the dynamic memory that you created. So at the end of your program, when you're done with this code, so basically when you're done with the dptr, you need to delete it. And deleting it allows you to have the memory free. If you don't use delete and you fail to do this properly, you could have memory leaks where the program continues to use memory that's no longer needed. That's not good. You don't want to dedicate memory to something that you don't mean to be running. So that's how you would use dynamic memory allocation. Again, you would just have a new double, you would have the pointer to a null pointer, then you have to set the address to each other, so you have to tie them together, and then you're just assigning it to a new double. And then you can assign it later whatever you want. Make sure you delete it, and you can fill it in with any variables depending on what you have up here. That's going to be it for dynamic memory allocation. We have one last section to go before we finish this up, and then we're done, and we'll move on to another topic. So check all those videos out in the playlist link below the like button. If you have a question about any of this material or I want anything further explained, please leave a comment below.